This conference will now be recorded.
So, very good evening, students. Today, we'll be continuing the chapter communication system and the basic terminologies we were discussing. So far in the last class, we had discussed, we had a discussion on the introduction part of this communication system, and then we had learned the basic elements of a communication system, where we require this is the black box, it is or block diagram. So this part is the main part of a communication system, like it requires transmitter, then transmitting channel, then the receiver. Okay, obviously you need a source for the signal which has to be transmitted from one place to another, and you need user of that information. While the information is or signal is transmitted through the channel, on the way it accumulates noises. Okay, so actually the receiver receives a distorted signal, and after that the signal will be processed in the receiver. So that we have learned already in the last class, and we had started discussing few basic terminologies in communication system. So among all those basic terminologies, we have discussed what is called transducer. It is a device which can convert a particular energy or system from one form to another. Like I had given an example that electrical signal can be converted to optical signal, and optical fibers are used as channel or the medium to transmit a signal. Electrical signal which is converted to optical signal can be transmitted via optical fibers from one place to another. So nowadays the era is for optical fibers. So everywhere the communication is much more faster than any other kind of uh, like any other kind of channel or communication medium. Okay, then we had discussed what is signal. Signal is actually some kind of message or information which is produced by some source, and that signal can be of two types. One is analog signal. Analog signal has a continuous variation, as we can give an example as sinusoidal signal. And when signal is given as a pulse or discrete values, so those signals are called digital signal, like a rectangular wave, etc. Square wave, rectangular wave, etc. These are kind of digital signal. Then we have discussed what is noise. Noise is actually unwanted electrical signals which interferes with the original signal, that we had already discussed. And we had discussed what is attenuation. Attenuation is the loss of strength of signal during the process of transmission from one place to another through the medium. So for electrical signal there is called something, there is a term called skin depth. For electromagnetic wave we'll learn sometime that. Okay, then we had discussed what is called bandwidth. Bandwidth actually refers to the frequency range over which an equipment operates, or range over which the frequency of the signal varies. That means there is a signal. So bandwidth we had discussed. Bandwidth. I'm just repeating this, Deepa, for you. What are the terms we have discussed? So bandwidth means, suppose a signal has frequency over the range, suppose some 10 kilohertz to some 100 kilohertz. Okay, 100 kilohertz. If some signal has frequency range, okay, so this is called range, 10 to 100. This is called range. And what is bandwidth? Generally, it is written as BW sometime. So it is the difference between the highest and the lowest signal. So it can be, bandwidth is 90 kilohertz. Okay, 90 kilohertz. So similarly, there is bandwidth. It refers to the band of frequencies of the original signal. That means, see, signal will be sometime processed by modulation process, etc. But based, there is, so this is bandwidth. There is something called base width. Base width. This is the range. This gives the range of the frequencies of the original signal. Okay, similar thing, bandwidth of original signal. That's all base width. So bandwidth of original signal is called base width. Now today, upon discussing all those, we will discuss today what is called modulation. Actually, these are the term modulation, demodulation, repeaters. Obviously, this modulation and demodulation will be discussed again in a special class, because there are different types of modulation. There will be frequency modulation, that is in short FM. Radio is used, like radio uses this FM mode, or sometime AM mode. AM is amplitude modulation and FM is frequency modulation. So those things we will discuss in detail later, but today we'll just learn what is called modulation and what is called demodulation. Okay, and repeater also has a great importance in the transmission of signals from one place to another. Okay, so let us learn what is called modulation. See, we have various kinds of frequencies, right? Signals. So sometime we have low frequency signal, we can have high frequency signal. So if I have a low frequency signal, which has to be transmitted from one place to another. So when we transfer such kind of low frequency signal, see, we have already learned that is something called attenuation. Okay, attenuation, that means loss of energy, loss of strength of the signal will happen. So if a low frequency is transmitted for a long distance, then it is very difficult to get proper information at the receiver because of this attenuation. There will be loss of signal. That's why, what is being done, a particular low frequency signal is actually just encapsulated with a high frequency carrier wave, or superimposed with a high frequency. I'm writing high frequency for HF, like HF for high frequency signal, so which actually act as a carrier signal. Carrier signal. See, in medical science, there is called drug delivery. Sometime you will see in the medicine, there will be, like, the original medicine is different than the carrier one. So some things will be there in the medicine which will act as carrier. Okay, carrier. Similar to that, this low frequency signal, when we transmit from a particular place to very long distance, then it may get attenuated, then original frequency will be lost. To protect the signal from getting it lost, what is done is called modulation. What is the modulation? Here is the definition given. Modulation is the process in which some characteristics, usually amplitude or frequency or phase angle, of a high frequency carrier wave is varied in accordance with the instantaneous value of low frequency signal called modulation. I'll tell you from this figure. Okay, suppose just just a minute. Okay, I'll just push this figure a little up. Okay, so that you see it completely. Okay, so see, there are different types of modulation, but here you can see modulating signal. This is the carrier signal. Okay, sorry, modulating signal. This is the low frequency signal. So this is the original low frequency signal. Low frequency signal. Then this low frequency signal will be superimposed with this frequency. This is the high frequency carrier wave. Okay, this is carrier wave, as you see from the like here. So this is carrier wave. You can see that. See, this has very low frequency, but this has frequency means what? Number of full cycles. Okay, so like if something has some signal has more number of variations in a second, complete cycle in like see how many complete cycle is uh is covered or is completed, that is actually called frequency. So look here, this is one complete cycle up to here, this is one complete cycle, but up to here you look, if you compare this to signal, it has how many complete cycle? One, then two, then three, then you have four, okay, five, six. So it has 6 times greater frequency than the original low frequency signal, right? So there are 6 complete oscillations. Here it has only one complete oscillation up to here. So this is a low frequency signal, and this is very high frequency signal. 6 times greater frequency it has. So if it has frequency f0, this has 6 f0. Now these two signals, if you superimpose, look how it will be looking like. See here, up to this, see these are having maximum amplitude, and this also has maximum amplitude during this time, like it has positive uh, variations. Okay, so anyway, here you can see that these are actually matching in phase or superimposed in phase. So you will look here more variation, but this place you look, these are having positive variations, but this has negative variation, so difference will have low frequency up to here, like during this time interval t by 4 t half. During this t half, so frequency will be less. So sometime frequency is more, sometime less, sometime again for some duration it will be again more. So this is how frequency is modulated. If I just draw this envelope, okay, this is actually frequency modulation. So frequency modulation, I cannot draw envelope. Anyway, you can see that, you can see the portion here, this particular portion up to here, this has greater frequency than both of them, and this has lesser frequency than the carrier wave. Okay, again it has greater frequency, like that it is modulated. Modulated means now the original signal is not there. Original signal is superimposed with this signal which has a greater frequency, and this is called carrier waveform, and the superposition is this one. Resultant of the superposition of these two waves is this one. Actually, this signal when transmitted, then attenuation will not affect too much the original signal. Okay, original signal. Then at the receiver, it will be received, and at the receiver again, this is called modulation. When you are superimposing, there will be demodulation. Demodulation means again the original signal will be extracted out of the carrier wave. Okay, so this is the modulated signal. So modulated signal will be again divided into or separated into original signal, low frequency signal, and high frequency carrier wave. So this is how modulation is being done. So so modulation is the superposition of a low frequency wave with a high frequency wave for transmission purpose. Okay, so that low frequency original signal is not attenuated or lost. And what is demodulation? Demodulation is the reverse process. Just reverse process is called demodulation. So the process of recovering the original signal from the modulated signal at the receiver end is called demodulation or detection. It is just the reverse process of the modulation process that occurs in the end, transmitting end. Okay, so actually modulation is done at the transmission end. Transmission, sorry. Modulation is done at the transmission end. What is being done? Low frequency signal will be superimposed with high frequency signal. Not only frequency, even see with the phase also it can be done. Same thing can be done with amplitude also. So low amplitude signal can be superimposed with larger amplitude signal, and that can be transmitted. Okay, so modulation is being done in the transmission end, and the demodulation, which is just reverse process. Demodulation, that means original signal will be getting back over there from the modulated signal. So demodulation is performed or done at the receiver end. Okay, so all right, so we have learned what is called modulation of signal and demodulation of signal also. Now we'll learn another term called repeater. This repeater is also very important in transmission of signal from one place to another. So what it does actually, see whatever tower, like we see, like these are kind of towers, okay, or reflector. These towers are actually repeater. Okay, this is given in many places. In city you may find many of them. Okay, for mobile, like radio signal, for radio, our telephone communication system, they do it. So signal while passing through transmission medium may get attenuated due to various energy losses that we have seen already. Attenuation, there is a factor called attenuation. So signal may be lost, due to various source of loss of energy. There will be various kind of loss of energy, various kind of source of loss of energy in the medium. Okay, so due to the loss, original signal itself may get attenuated or lost. So to protect the original signal of being lost, there are something called signal booster. Signal booster. Signal booster or amplifying repeater. Booster or amplifying repeater. So let me tell you first. Actually, these repeaters are called amplifying repeaters or booster. See, some signal is actually just propagated. Sometime it will be lost. Okay, some lost in the sense some it will lose its strength along the path of the transmission. It will lose its strength. So that time what is done? More signal will be added to it. That is called boostering. Okay, more signal. The original signal itself will be just amplified little bit, so that the original signal is back again and it is transmitted in through the medium again. Okay, so what is done in the repeater? What are there with the repeater? Actually, repeater is a combination. I'll write over here. Repeater is a combination. It is actually signal boostering device, or so repeater is a combination of a transmitter. Okay, see, these are the things we have in the beginning itself. So it has, see, repeater station. Any repeater station has a transmitter. Then you have amplifying action, so you need an amplifier, and finally you have again a receiver. Okay, so it has a receiver, transmitter and amplifier, both, all three. Okay, so what it does, see, these are repeaters. Okay, these are repeaters. So what they have, first of all, they will receive it, picks. So picks the, what is the role? Picks the signal. It will pick the signal first. Then what is the role? After that, it will amplify the signal, so that the original signal is not lost. And then it will retransmit from here. Retransmit. So these are the role. These are the role of a repeater. So it will first receive or picks up the signal, then it will amplify and then retransmit from there through the channel. Okay, so these are the roles of a particular repeater. Actually, multiple repeaters are placed at a suitable distance along the transmission path. So this extends the range of the communication. Suppose you have a original signal emitter somewhere at 10 kilometer away from your home, but you are getting the signal from there. So in between your home and the original station, you need many such repeaters so that you get the original signals transmitted at the original station. Okay, so a communication satellite is essentially a repeater station. Communication satellite is one of the example of repeater station. Okay, repeater station. A communication satellite is a kind of repeater station. Okay, so this is so we have already learned uh, these basic terms. So now we'll slowly get into the subject matter. Now we'll learn bandwidth of signal a little in detail. Bandwidth of signal we have already learned. So a signal can vary over a range, like signal frequency can vary over a range that we have already learned. So there will be low frequency, then there will be a like lowest frequency, there will be highest frequency, and there will be frequencies in between. Okay, now the difference between the highest and the lowest frequencies is called the bandwidth. We have already discussed that. So here what new we will be discussing, and there are some interesting point to learn here. See, we have three types of signal mainly. How many types of signal? Actually, we have already learned. There will be analog signal, analog signal, we have digital signal that we have been learning from last chapter itself. Digital signal has discrete values over a particular time interval, but analog signal has values continuous varying time varying quantity, like a sinusoidal wave. This is some kind of rectangular or square wave. Okay, so just a minute, I'm getting a call. Excuse me for this. Yeah, I'm back. So message signal, we have learned that there is something called message signal or signal. So this message signal can be of different type. So in general, analog and digital, that is fine, but these types are actually okay. So see, we have message signal, kind of voice message, voice, okay, voice signal or message. We can have a still picture, okay, still picture signal or message, or we can have some music. So generally these are different types of signals. Okay, these are different category of signals. So this different type of signal may have different frequency range. So these all will not fall in the same frequency range. They have different frequency range. Okay, so while transmitting a voice signal or picture signal or music, sorry, music is only C, music signal, you need to actually choose different types of transmitting medium or channel. Different types of channel you have to use. Why? Because the frequency ranges are different for different message signal. Like voice signal, you need some particular bandwidth. You picture signal, you need a particular bandwidth, and music signal, you need a particular bandwidth. So the range over which frequency in an information signal vary is called bandwidth. That we have already learned what is called bandwidth. Now we'll take up few examples, like see if I say speech or speech or voice signal. Generally, we use radio, right? For this medium is radio. So it contains, see, it has frequencies varying between 300 hertz to 3100 hertz. So in between, signal will vary, speech or voice signal. Okay. So for this kind of signal, you need a medium, transmitting medium, which can provide a bandwidth, how much? Here you just subtract it, the highest and lowest. So bandwidth, you require a medium which has bandwidth this much, right? 2800 hertz bandwidth. You need a medium which can provide a bandwidth, like in telephonic transmission. Actually, this is in telephone also. Telephonic transmission. So for telephonic transmission, what is the bandwidth generally being used? That is 2800 hertz. This is very, very interesting because we use this kind of systems, but we don't know much about them. So now this is an opportunity to learn what are there in the communication system, okay, which we daily use, but we don't know. We will be able to understand something about those in this chapter. Okay, so telephonic system, like telephonic transmission, we use uh, a medium which has a bandwidth, a signal bandwidth 2800 hertz. Now I was telling you about audio signals. See, audio signal, this is speech or voice. So in this we have audio signal also. Audio signals, generally sound. Audio means sound. So this audio signal, this has frequency. Signal has frequency 20 hertz to all the way up to 20 kilohertz, right? This is the frequency range. Okay. So what is the bandwidth you need then in this case? Actually, you need, for good transmission of music, for good transmission of music, good transmission of music, you need bandwidth about how much? About 20, nearly 20 kilohertz. Because 20 hertz, if you subtract from 20 kilohertz, that will be nearly equal to 20 kilohertz only. So you need bandwidth BW. So 20 kilohertz bandwidth is required to transmit music signal from one place to another. Now we have video signal, right? So in case of video signal, like in television, etc., you need, for video signal, you need bandwidth around 4.6 megahertz. Okay, video signals required for transmission of pictures have a bandwidth about this much megahertz. Okay, 4.2 megahertz. Now a TV signal actually used, see, for TV signal, generally TV signal used, a TV signal which contains both voice and picture, actually bandwidth is nearly 6 megahertz is allocated, because it has, see, in this range, you will have both the audio and video, right? Voice signal, and you need still picture signal also. So both audio and video can be seen or transmitted through a medium which can provide a bandwidth of something like 6 megahertz. Okay, so these are the informations you should remember for simply audio signal, for simply picture or still picture, for television, like television uses 6 megahertz for both voice and picture, etc. So these are few informations you have learned. Okay, now we have already talked about analog. These are kind of all the other signals are kind of analog signals, whatever we have discussed so far. Okay, like sinusoidal signal is an analog signal, right? But whereas square or rectangular wave is a digital signal. Now, this, sorry, here I had some analog and digital signal representation. Now see, we will try to understand that a rectangular signal, whether a rectangular signal can be decomposed. The rectangular signal means you have kind of this and this. Okay, let me draw it a little more properly. Okay, this kind of signal is called rectangular signal. Okay, because see, during this time interval you will get some value, suppose 5 volt. Always it will be 5 volt, one number you are getting. As soon as the time becomes this, so this is time axis, suppose when the time reaches to this particular t1, suppose this is t1 and this is t2. So when it reaches to t1, it will exactly become 0 and it will go to the other side, negative. It will immediately go to the other side, minus 5 volt. This is suppose minus 5 volt, and it will continue to have, like, it will continue to see, like it will continue to show minus 5 volt during this t1 and t2 interval of time. Again, when t2 time is reached, then you will have another plus 5. So basically you are getting some numbers plus 5 or minus 5. Okay, always you are getting either plus 5 or minus 5. So these are discrete numbers, so that's why it is called digital signals. Okay, so we will see here, if you look this figure A, that is a solid line over here, the solid gray line, this is a rectangular signal. So if we want to construct or produce a rectangular signal, whether we can use the analog signal, sinusoidal analog signal itself, to produce a digital signal. The see here, the context is very interesting. Look, we are getting digital signal out of analog signal, whether it can be done or not. So that is the main point which we'll be discussing here. What is that point I will discuss here? We'll discuss here that whether from analog signal, basically sinusoidal signal, will help us to produce a digital signal which is of the form of a rectangle or rectangular wave. Okay, it is yes. See here, B, C, and D. These are actually sinusoidal signals. See B, this is B, this is B, and this is D. So these are actually sinusoidal signals with what? With various harmonics. With various harmonics. So one can decompose a rectangular wave into superposition of sinusoidal waves. Suppose you have some, see, this B is actually a fundamental frequency of sinusoidal wave. It has frequency f0. Then if you have your second harmonics, like superposition of f0 plus 2f0, that means f0 plus f0, 2f0. So this is the fundamental, this is first harmonic. Then you have f0 plus 2f0 plus 3f0. That means you have fundamental, then first harmonic, second harmonics. Okay, if you go on to add the higher harmonics with the fundamental, like, and superpose them, then you will see your signal on an average will give you a rectangular kind of signal. So we can decompose a rectangular wave into a superposition of sinusoidal waves of frequencies f0 to f0. Actually, you have to superimpose all the higher harmonics with the fundamental frequency. Suppose if we go up to n like that, so f0, then its first harmonics, to f0 plus dot dot up to nth harmonics. If we go, then approximately we will get a rectangular digital signal. And so this n can go up to infinity. It can go up to infinity. Okay, that means how much bandwidth you have here? Nearly infinite bandwidth you will have here. Okay, you'll have nearly infinite bandwidth. Are you able to hear me now? I saw the message just a second back. Guna madam, are you able to hear me? Okay, fine, fine. So how long was it like muted? Okay, anyway, I'll just repeat this thing what I was discussing. So here I'm discussing that a digital signal, or basically rectangular signal, can be decomposed into a superposition of sinusoidal waves of frequencies nu 0, as you see here, like, or here I was writing f0. Let me stick to f0. F0 is the fundamental frequency or first harmonics. Then along with that if you superimpose the higher harmonics, then if we go, let us say we go up to nth harmonics, then bandwidth will be nearly infinite. Okay, so at this situation you will actually find, if you superimpose a particular harmonics, like fundamental, this one fundamental, then see there are harmonics, like see it has both fundamental and like first harmonic and second harmonics, then this one has, see how much variations, so it is having actually f0, then 2 f0 plus 3 f0 also. So like that, if we superimpose the higher harmonics with the fundamental harmonics, it will actually nearly produce a rectangular signal. Okay, so clearly to reproduce a rectangular wave shape signal, we need to superimpose all harmonics, and this implies an infinite bandwidth. And practically from the higher harmonics there will be negligible contributions which limits the bandwidth. So as the higher harmonics, like frequency of the higher harmonics increase, their contribution to the waveform will be lesser and lesser. So anyway, you can just go through this part from the NCERT textbook also, it is nicely given over there, and see, if you superimpose the fundamental one with its all harmonics, then it will nearly give you or help you to produce a rectangular shape waveform. See, if I just draw with infinite number of or large number of harmonics, see what I will see. I'll see somewhat like this, like this. Okay, then it will go in the other direction. Then what I get like this, and then it will go like this. See, it is nearly a rectangular waveform. Okay, so you will get like this. So we can have an average value over here, then here an average value of this waveform, so you will get a rectangular one. Okay, so it is already going to be the time. I would like to discuss about the types of communication system, but it will take time, so I will not start today. Next day we'll see, according to different bandwidth, different medium or transmission system has been used. Like for speech transmission, radio is being used. For picture as well as speech transmission, television is being used. Fax is being used for remote transmission of documents, still figures. Data transmission in a computer. Like that, there are various communication systems according to various frequency band, etc. Okay, so those things we'll discuss in the next class. Along with that, we'll try to understand types of modulation, like frequency modulation and amplitude modulation. Okay, so I'll stop it here for today, and next class we'll discuss various type of modulation in detail and also different types of communication systems. Okay, so we'll stop it here for today. Deepa, if you have any questions, you can ask me now. Okay, if you don't have any question, I'll stop it here. I can take up your question in another session also. If you have, you just first read from your textbook. If you don't understand, please ping me. All right. So bye for today.